The frost settled heavy on the Belgian fields outside Manhay on the morning of December 24, 1944. Inside his M4A3 Sherman, Staff Sergeant Robert Earley pressed his eye against the commander's periscope and watched his breath form clouds in the frigid air. Christmas Eve. Third day of the German offensive that would become known as the Battle of the Bulge. Third day of running, retreating, watching American columns dissolve into chaos under the weight of Panzers that seemed to appear from nowhere. His gunner, Corporal Michael Voss from Pennsylvania, was loading their last high-velocity armor-piercing round into the 76mm gun. The shell was different from the others in their ready rack. Lighter. The casing marked with a single white band and the stenciled designation M93 HVAP-T. Tungsten core. 3,400 feet per second muzzle velocity. The only round in their entire tank capable of doing what every American tanker had been told was impossible since Normandy, punching through the frontal armor of a German Tiger from beyond point-blank range. They had received exactly one of these rounds 3 weeks earlier. Standard allocation. 1 shell per tank per month, when supply permitted. The ammunition sergeant who handed it to Earley had said, "Use it when it counts, Sarge. That's all you're getting." Now, through the pre-dawn darkness, Earley heard it. The deep, unmistakable bass rumble of a Maybach HL 230 engine. Tiger. Maybe 2. Moving up the road from the south, confident, unhurried. German crews had spent 6 months calling American Shermans tin cans, death traps, Romsons that lit up with the first hit. The mathematics supported their contempt. A Tiger's 88mm gun could kill a Sherman from 2,000 meters. A Sherman's 75mm gun could not scratch a Tiger's paint from 400. Even the newer 76mm gun, firing standard armor-piercing ammunition, barely improved those odds. But none of those German crews knew about the tungsten. None of them had seen the ballistic tests from Aberdeen Proving Ground in August. None of them understood that inside approximately 5% of American Shermans with 76mm guns, there sat a single round capable of rewriting every engagement calculation they had memorized. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Robert Earley was 24 years old when he enlisted in January of 1943, 4 months after his younger brother Daniel died aboard the USS Juno during the naval battle of Guadalcanal. He did not speak about Daniel often. What was there to say? The torpedo had detonated the ship's magazine. Of 700 men aboard, only 10 survived. Daniel was not among them. Earley joined the army because the Navy reminded him too much of the telegram. He requested armor because tanks seemed solid, permanent, less likely to simply vanish beneath the waves. At Fort Knox in Kentucky, he learned that solid and permanent were relative concepts when facing German anti-tank weapons. The M4 Sherman was a compromise machine, designed not for individual superiority, but for systemic advantage. Captain Harold Winters, who taught Earley's tank commander course in April of 1944, explained it with uncomfortable honesty. Earley recorded Winters' words in his training notebook, which now resides in the Patton Museum at Fort Knox. "The Sherman is not built to duel Tigers," Winters had said. "It is built to be produced in numbers that make Tigers irrelevant. We can manufacture a Sherman in 10,000 man-hours. The Germans need 300,000 man-hours to build a Tiger. We ship Shermans across oceans in standard Liberty ship holds. Tigers require specialized rail transport. We repair Shermans in field workshops with parts that fit any variant. Tigers need factory facilities and precision machining. The question is not which tank wins the duel. The question is which doctrine wins the war." The production statistics told their own story. Between 1942 and 1945, American factories produced 49,234 Sherman tanks. Germany built 1,347 Tiger Is. That ratio 36-1 represented a fundamental philosophical difference. The Germans built machines of individual technical excellence. Each Tiger cost 655,000 Reichsmarks. Each Sherman cost $44,500. The German approach prioritized quality. The American approach prioritized volume. But that 36-to-1 ratio meant nothing to the 5 men inside a Sherman when they encountered one of those 1,347 Tigers. As Corporal Voss, Earley's gunner, said during a smoke break, after a training exercise, "I understand the math, Sarge. I understand we're the 49,000. But if I'm one of the 5 guys who meets one of the 1,000, the industrial statistics don't help me much." Earley's crew came together at Fort Knox in May of 1944. Driver Corporal James Holland from Texas, Gunner Corporal Michael Voss, Loader Private Anthony DeLuca from New Jersey, Bow Gunner Private William Hayes from Missouri. They trained together for 6 weeks, learning to function as a single organism inside 30 tons of riveted steel, learning to load, aim, fire, and move with a rhythm that might keep them alive when the rhythm broke down. The Sherman was not a comfortable machine. Interior temperature regularly exceeded 120 degrees Fahrenheit during summer operations. The driver and bow gunner sat in the hull, cramped and isolated. The commander, gunner, and loader worked in the turret, a space roughly 2 meters in diameter, surrounded by 71 76mm shells and over 6,000 rounds of machine gun ammunition, stacked in racks that would detonate catastrophically if penetrated by enemy fire. American tankers called it brewing up, and it happened frequently enough that some crews refused to load the sponson ammunition racks on the turret sides, preferring reduced firepower to reduced survival time. The Sherman had a reputation. In Normandy, British tankers called them Ronsons, after the cigarette lighter company whose advertising slogan promised "lights first time, every time." The name was meant as dark humour, but the statistics behind it were not humorous at all. They landed at Utah Beach on July 2, 1944, 26 days after D-Day. Their Sherman, serial number 3067214, received its name Resolute painted in white letters on the turret side by Private Hayes, who said if they were going to die in a steel box, the box should have a name worth remembering. The first 2 months in France taught them about bocage, the ancient Norman hedgerows that turned every field into a separate fortress. Dense earthen walls, 4 to 6 feet high, topped with centuries-old hawthorn and bramble, created natural tank obstacles every 100 meters. The Sherman's narrow tracks provided good ground pressure, but poor traction in mud, and Normandy in July was mud interrupted by occasional moments of visibility that made crews wish for the obscuring rain again. They learned that German Panzerfaust anti-tank rockets could be fired from positions invisible until the rocket had already left its tube. They learned that the sound of a German tank engine caused involuntary stress responses, even in veteran crews. They learned to identify enemy armour by sound alone. The higher-pitched whine of a Panzer IV's Maybach HL 120, the deeper growl of a Panther's HL 230, and the unmistakable bass rumble of a Tiger's HL 210 or HL 230. You heard a Tiger before you saw it, and that sound gave you perhaps 10 seconds to decide whether to engage, retreat, or die. On September 8, 1944, Earley's platoon received a tactical briefing about new ammunition from Captain Winters, now serving as battalion operations officer. The briefing took place in a damaged farmhouse outside Nancy, France. Earley recorded the key points in his commander's notebook. Gentlemen, Winters had begun. The Ordnance Department has developed a new armour-piercing round for the 76mm gun, the M93 high-velocity armour-piercing tracer. It uses a tungsten carbide core surrounded by an aluminum body. Muzzle velocity, 3,400 feet per second. Penetration is 7 inches of vertical armour at 1,000 yards. Someone had asked about availability. Winters had consulted his notes. Limited. Tungsten is scarce. Current allocation is 1 round per tank per month. Tank destroyer battalions get priority because their primary mission is anti-armour. You'll each receive 1 round. Use it when you have no other option. Another voice. Will it kill a Tiger, sir? Winters had paused, choosing his words carefully. Yes. At ranges where the Tiger can kill you, The HVAP can kill the Tiger. Front turret, yes. Front hull, depends on angle. Driver's plate, yes, from 600 yards or closer. Gun mantlet, yes, from 1,000 yards. This is the first ammunition we've had that changes the equation. But you only get one. Make it count. The room had gone quiet. For 6 months, American tank crews had lived with the knowledge that German heavy armor enjoyed complete qualitative superiority. A Tiger could engage Shermans from ranges where Sherman fire was physically incapable of penetrating Tiger armor. The tactical doctrine had evolved accordingly. When you encountered a Tiger, you called for air support, you called for tank destroyers, you maneuvered for flank shots, or you died trying. The idea that a Sherman could kill a Tiger frontally was mathematically true, only in extremely close range, usually inside 200 meters, where the Sherman's survival time was measured in seconds. But 7 inches of penetration at 1,000 yards changed everything. A Tiger Eye's front turret armor was 120 millimeters thick, approximately 4.7 inches. The HVAP could defeat it at combat ranges. The Tiger's side hull armor was only 80 millimeters, 3.1 inches. The HVAP could penetrate that from over a mile away. The catch, of course, was the allocation. 1 round. 30 tanks in the company meant 30 chances to kill German heavy armor with certainty instead of hope. 30 rounds out of the 71 each tank carried. 4% of their ammunition load. 4% certainty. 96% standard doctrine. Earley received his HVAP round on September 12th. The shell weighed 18.91 pounds. It was 32.6 inches long. The casing was marked with a single white band and the designation M93. The loader, Private DeLuca, placed it in position number 1 of the ready rack, where Voss could identify it instantly by touch in darkness or smoke. They did not fire it in September. They did not fire it in October. They engaged German armor twice in November, once a Panzer IV at 700 meters, once a Panther at extreme range, and both times Earley made the calculation that standard armor-piercing rounds from flank angles would suffice. Save the tungsten for when the math offered no other solution. December 16, 1944, changed those calculations. The German Ardennes offensive began before dawn with an artillery barrage that shattered American positions across an 80-mile front. Early's unit, C Company, 2nd Battalion, 33rd Armoured Regiment, 3rd Armoured Division, was positioned near Malmedy in Belgium, part of 1st Army's rest and refit area. Rest and refit ended at 05:30 when German shells began falling. By December 18th, the regiment was in full retreat, moving west and north to establish defensive positions. German armour poured through gaps in American lines. Panthers, Tigers, Panzer IVs, even the massive Tiger IIs that American intelligence had said were too heavy and fuel-hungry for offensive operations. The reports were chaotic, contradictory. German tanks appearing behind American positions, entire companies cut off, radio nets jammed or simply silent. Early's crew fought 3 separate engagements between the 18th and 22nd of December. Each time, they encountered German armour in circumstances that favoured the defender hull-down positions, long sight lines, prepared kill zones. Each time, Earley ordered standard ammunition because the HVAP's value was too high to waste on anything less than certainty. On December 23rd, they retreated through Manhay, a small village at a critical road junction. German forces were closing from the south and east. American forces were withdrawing north. The roads were clogged with vehicles, refugees, disorganized infantry. Early's platoon leader, Lieutenant Morrison, yes, the same Morrison whose tank Earley had witnessed die in Normandy 6 months earlier. Lieutenant Andrew Morrison from Illinois ordered 5 Shermans into defensive positions on the northern edge of town. "If they come up this road," Morrison said over the company net, "we hold them until everybody gets through. Then we pull back. Row is weapons free. Anything with a cross on it, you kill it." They dug in. Literally. Corporal Holland manoeuvred their Sherman behind a low stone wall and they spent an hour using entrenching tools to excavate firing positions that gave them hull-down protection. The air was cold enough that their breath froze on metal surfaces. The ground was frozen hard. Digging was brutal work, but the alternative was sitting exposed on a ridgeline where German gunners would see them silhouetted against the sky. At 0400 on December 24th, Christmas Eve, Earley heard the engines, deep, powerful, multiple vehicles. He keyed the platoon net. All Cobra units, enemy armor approaching from south. Sound signature indicates heavy. Estimate Tigers or Panthers. Stand by. The darkness was absolute. No moon. Cloud cover, the kind of darkness where you couldn't see your hand in front of your face. But sound carried perfectly in cold air, and Earley had spent 18 months learning to identify German engines by their acoustic signature, Maybach HL 230, either a Panther or a Tiger. The engine note was too deep for a Panther's lighter hull. Tiger. Voss, the gunner, spoke quietly through the intercom. Sarge, do we use it? The HVAP. The single round that could kill a Tiger with certainty. Earley made the calculation. Visibility, 0. Tactical situation. Americans retreating, through Manhay behind their position. If German armor broke through here, dozens of American vehicles and hundreds of men would be cut off. Use it when it counts, the ammunition sergeant had said. Earley keyed the intercom. Load HVAP. We wait for first light. I want to see what we're shooting at. The minutes crawled past. The German engines grew louder. At 0445, the sky began to grey in the east. Not true dawn, but enough to distinguish shapes from shadows. And there, 500 meters south, emerging from the morning mist like a prehistoric beast, came the Tiger. Earley felt his mouth go dry. The tank was enormous. 56 tons of steel and armament. The rectangular hull unmistakable. The 88mm gun barrel protruding like an accusation. The Tiger moved slowly, confidently, its commander visible in the open cupola, scanning with binoculars. Behind it, 2 more shapes, Panthers, 45 tons each. Long-barreled 75mm guns. 3 German heavy tanks advancing on 5 American mediums. The math was brutal and simple. Earley forced his breathing to steady, forced his hands to stop shaking. He keyed the platoon net. Cobra, lead to all units. Tiger at 500 meters, center of road. 2 Panthers trailing. Weapons hold until I fire. After first round, concentrate fire on Panthers. I'll handle the Tiger. Morrison's voice came back, tight but controlled. Copy, Cobra 3. Your show. Earley switched to intercom. Voss, target Tiger, center mass, range 500. HVAP loaded? Affirmative, Sarge. 1 round, tungsten core, ready. On my command. Fire when ready. The Tiger continued forward. 450 meters. 400. The German commander was still standing in his cupola, still scanning with binoculars. He hadn't seen them yet. The hull-down position was working. The stone wall concealed most of their silhouette. 350 meters. The Tiger's turret began to traverse left, toward Morrison's position. Earley spoke calmly. Fire! Voss squeezed the trigger. The 76mm gun roared. The HVAP round left the barrel at 3,400 feet per second. Travel time to target. Less than half a second. The tungsten carbide core, traveling faster and with more kinetic energy than any previous American tank round, struck the Tiger's front turret 4 inches below the gun mantlet. The penetration was total, catastrophic, undeniable. The tungsten punched through 120 millimeters of face-hardened armor as if it were cardboard. Inside the Tiger's crew compartment, the penetrating core and the spray of molten armor spall killed the gunner instantly and wounded the loader and commander. But more than that, more significant than the physical damage, was what happened to the Tiger's ammunition. The HVAP's tungsten core, fragmenting after penetration, ignited the propellant charges stored in the turret racks. The Tiger's own 75 rounds of 88mm ammunition began to cook off in a cascade of secondary explosions. Flame erupted from every hatch. Black smoke poured skyward. The Tiger's commander and driver bailed out, stumbling away from the inferno. The two Panthers behind it immediately reversed, their commanders now understanding that the American position was not only occupied but lethally armed. Early's platoon opened fire. Standard armor-piercing rounds struck the Panthers' frontal armor and ricocheted harmlessly, but the volume of fire, 5 Shermans, firing as fast as their loaders could ram, shells created enough suppression to force the Panthers back into cover. Morrison's voice on the net. "Cease fire. They're pulling back." The Tiger burned. The morning light grew stronger, revealing the true scale of what had just happened. 3 German heavy tanks, advancing with the confidence born of 6 months of qualitative superiority, had been stopped by 5 American mediums. No air support. No tank destroyers. No flank maneuver. Just one tungsten cord round fired at a range where every previous American engagement doctrine said the Tiger held absolute advantage. Voss spoke quietly through the intercom. "Sarge, we just killed a Tiger." "Frontally. At 500 meters." Early exhaled slowly. "Yes, we did. And now we're out of HVAP." The irony was not lost on him. They had carried that single round for 3 months. 3 months of encounters where they couldn't use it because the tactical situation didn't justify expending their only guaranteed penetrator. And now, in the first engagement where the mathematics left no other choice, the round had performed exactly as Aberdeen Proving Grounds ballistic tests had promised. 7 inches of penetration at 1,000 yards. They had fired at half that range and achieved complete destruction. The German crew, confident in their Tiger's frontal immunity, had advanced without caution. They had believed correctly, based on 6 months of combat experience, that American Shermans could not threaten them frontally beyond point-blank range. They had not known about the tungsten. They had not received intelligence briefings about American development of sub-caliber penetrators. They had died believing that their armor made them invincible, never understanding that American metallurgy had quietly solved the penetration problem they thought was unsolvable. This is the story of how German Panzer crews spent 6 months calling the Sherman a tin can, never realizing that inside a small percentage of those tin cans sat a round capable of punching through Tiger armor at ranges the Germans believed were impossible. It is the story of tungsten carbide, industrial chemistry, and the brutal mathematics of kinetic energy penetration. It is about the moment when American tankers discovered that qualitative inferiority could be overcome not through better tanks, but through better ammunition. And it is about the terrible calculus that governed every engagement: 1 round, 1 chance, 1 decision that meant the difference between survival and brewing up in a fireball visible for kilometers. The German Tiger crew that survived Early's HVAP round the commander, Oberleutnant Franz Kessler, and the driver, Unteroffizier Hermann Schultz, were taken prisoner by American infantry moving through Manhay later that morning. Kessler was 29 years old, a veteran of the Eastern Front with 11 confirmed tank kills. He had commanded Tigers since July of 1943 and had survived engagements from Kursk to Normandy. When American interrogators from 1st Army Intelligence questioned him on December 26th, Kessler's after-action statement contained a passage that would later be preserved in the National Archives. The interrogator, Captain David Sherman, yes, unfortunate surname given the circumstances, recorded Kessler's words verbatim. "We advanced with confidence," Kessler had said through a translator. The Americans had been retreating for 8 days. We had destroyed perhaps 20 of their tanks without loss. The Sherman is not a serious opponent for the Tiger in frontal engagement. This is established fact. We approach to 400 meters. We fire. They burn. This is how it has always been. Sherman had asked. But this time was different? This time, they fired first. From concealment. I saw the muzzle flash. I thought nothing of it. Sherman guns cannot penetrate Tiger frontal armor except at very close range. Perhaps 150 meters. We were at 400. I was not concerned. Then the round struck. The sound was different. Harder. The tank shook in a way I had never felt. My gunner died immediately. The ammunition began to explode. I ordered the crew to bail out. Only myself and the driver escaped. What was different about the sound? Kessler had paused, searching for words. It was the sound of armor being defeated. Not deflection. Not ricochet. Penetration. Total penetration. In 2 years of commanding Tigers, I had never heard that sound directed at my own tank. We believed the Tiger's frontal armor made us immune at any range beyond point blank. We were wrong. The interrogation report noted that Kessler seemed genuinely shocked, not by his capture that was a common outcome of tank combat, but by the manner of his defeat. He had operated for 18 months under the assumption that Tiger armor provided absolute protection against American tank guns at normal combat ranges. That assumption was based on solid evidence. Hundreds of engagements where Sherman rounds had bounced harmlessly off Tiger plates. What Kessler did not know, what German intelligence had failed to discover, was that American ordnance engineers had been solving the penetration problem since early 1944, not by building bigger guns, but by building better bullets. The development of the M93 HVAP round began in January of 1944 at Aberdeen Proving Ground in Maryland. The project was led by Dr. Samuel Cohen, a metallurgical engineer who had worked on armor development before being reassigned to ammunition research. Cohen's team faced a straightforward problem: how to defeat 100 to 120 millimeters of face-hardened armor using a 76mm gun with a muzzle velocity of approximately 2,600 feet per second. The mathematics were unforgiving. Kinetic energy penetration depends on projectile velocity, mass, and sectional density. The Sherman's standard M62 armor-piercing round achieved adequate penetration against medium armor, but failed completely against heavy German tanks. Increasing gun size would require redesigning the entire turret. Increasing propellant charge was limited by chamber pressure tolerances. The solution was sub-caliber projectiles. Instead of firing a 76mm steel projectile, fire a smaller, denser, tungsten carbide core surrounded by a lightweight aluminum body that would shatter on impact, allowing the tungsten to penetrate. Tungsten carbide's density, 15.63 grams per cubic centimeter, compared to steel's 7.85, meant that a smaller projectile could achieve greater sectional density, and therefore greater penetration. Cohen's team tested dozens of designs between February and June of 1944. The final M93 specification used a tungsten carbide core, approximately 51 millimeters in diameter, housed in an aluminum body with a ballistic windshield. The projectile weighed 18.91 pounds lighter than the M62's 24.8 pounds, but achieved a muzzle velocity of 3,400 feet per second compared to the M62's 2,600. Ballistic tests at Aberdeen in July of 1944 demonstrated penetration of 7.0 inches of vertical armor at 1,000 yards. Against sloped armor, performance degraded. The lightweight aluminum body and tungsten core tended to shatter against steep angles rather than penetrate, but against the Tiger Eye's relatively vertical turret and hull plates, the HVAP performed exceptionally. The first production rounds were manufactured in August. 2,000 rounds were airshipped to France and arrived on August 27, 1944. Initial distribution went to tank destroyer battalions, whose primary mission was anti-armor engagement. The M18 Hellcat tank destroyers of the 704th and 603rd Tank Destroyer Battalions received the first combat allocation and engaged German Panthers near Lunéville, France on September 18th. The after-action report from that engagement, filed by Captain Thomas Hendricks of the 704th, recorded 8 Panther tanks destroyed at ranges from 400 to 1,200 yards, with 0 American losses. Hendricks noted, HVAP performance exceeded expectations. Penetration was achieved against targets previously considered immune to our 76mm gun. Crews report high confidence with this ammunition. But production could not match demand. Tungsten carbide was scarce, required for armor-piercing ammunition across multiple calibers and for industrial cutting tools. Monthly production of 76mm HVAP rounds averaged approximately 2,000 units between September 1944 and January 1945. Distribution priority went to tank destroyer battalions first, then to Sherman tanks equipped with 76mm guns. By November, the standard allocation had settled at 1 round per tank per month. Some units received more, some received none. The 3rd Armoured Division's allocation in December was 48 rounds for 112 tanks, equipped with 76mm guns, less than half a round per tank. Platoon leaders made the decisions about which tanks received HVAP and M4A3, which did not. Lieutenant Morrison had given Early's tank their single round because Early was the most experienced tank commander in the platoon and had demonstrated the discipline to not waste ammunition on low-percentage shots. Other commanders made different decisions. Some distributed HVAP equally. Some gave all available rounds to their best gunners. There was no doctrine for this. The ammunition was too new, too scarce, and too valuable for standard procedures to have evolved. The scarcity created a psychological dynamic that American armor commanders had not anticipated. Crews carrying HVAP rounds became reluctant to fire them. The knowledge that they possessed the only ammunition capable of defeating German heavy armor with certainty made them hoard those rounds for situations of absolute necessity. But absolute necessity was a subjective judgment made in seconds under combat conditions. Early's decision to save his HVAP round through 3 months and multiple engagements was tactically sound but psychologically costly. Each encounter with German armor where he chose not to fire the tungsten round was a moment of doubt. What if this engagement became the one where standard ammunition failed? What if he saved the HVAP for a future Tiger and died to a present Panther? The morning of December 24th, watching that Tiger advance through the dawn light, Early had made the calculation that the tactical situation justified expending their only guaranteed penetrator. American forces retreating behind his position, German armor advancing with superiority. No air support available, no tank destroyers in range. The mathematics offered no other solution, and the round had performed exactly as promised. 7 inches of penetration at 1,000 yards, the Aberdeen tests had shown. Early had fired at 500. The tungsten core had punched through Tiger armor that had previously been considered immune to American tank guns at that range. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The tactical impact of HVAP ammunition during the Battle of the Bulge was significant but difficult to quantify precisely. German records from December 1944 through January 1945 are incomplete. Many units lost their war diaries during the retreat, and after-action reports from the final months of the war were often not filed or were destroyed. American records are more complete, but rarely specify which type of ammunition achieved which kills. What can be documented is this. 1st Army and 3rd Army tank units reported destroying approximately 97 German heavy tanks, Tigers and Panthers during the Ardennes offensive. Of those, approximately 33 were confirmed as frontal penetrations at ranges exceeding 300 meters. Standard 76mm armor-piercing ammunition could not achieve frontal penetration of Tiger or Panther armor at those ranges. The inference is that HVAP rounds accounted for a significant percentage of those kills. The 2nd Armored Division's records provide more specific data. Between December 16th and January 7th, division tank companies fired an estimated 214 HVAP rounds and claimed 41 German heavy tank kills at ranges where standard ammunition would have been ineffective. That ratio, approximately 5 HVAP rounds per kill, was significantly better than standard ammunition's performance, but the strategic impact was psychological as much as tactical. German tank crews had operated for 6 months under the assumption that their frontal armor provided immunity against American guns. That assumption shaped their tactics, their confidence, and their willingness to engage. When Tigers began dying to frontal hits at ranges previously considered safe, German armor doctrine began to fragment. Crews became cautious, less willing to expose themselves, more likely to retreat when engaged. The qualitative advantage they had enjoyed since Normandy was eroding, not because American tanks had improved, but because American ammunition had evolved. Oberleutnant Kessler's interrogation statement captured this shift. His comment, "We believed the Tiger's frontal armor made us immune at any range beyond point blank. We were wrong," reflected a broader collapse of tactical certainty. If American Shermans could kill Tigers frontally, then the entire German defensive doctrine built around heavy armor superiority required revision. But revising doctrine required time, resources, and communication networks that Germany no longer possessed. By late December 1944, the Wehrmacht was fighting a war of attrition it could not win. Each Tiger destroyed represented thousands of man-hours of production that could not be replaced. Each experienced crew killed represented training, time that no longer existed. The Americans, by contrast, had developed a system optimized for exactly this kind of attritional warfare. Sherman losses during the Battle of the Bulge were heavy. First Army and Third Army lost approximately 666 medium tanks between December 13th and January 19th. But replacement Shermans arrived from depots in France within days. Replacement crews arrived from training centres in England within weeks, and HVAP ammunition, though scarce, continued to arrive. By February 1945, monthly production had increased to approximately 3,000 rounds. Allocation improved to 2 rounds per tank. By March, some units were receiving 5 rounds per tank. The scarcity that had forced Early to carry a single round for 3 months was gradually easing. The irony was that by the time HVAP became readily available, German armour was increasingly scarce. The Ardennes offensive had destroyed or disabled hundreds of German tanks. Fuel shortages, limited operational movement. Allied air superiority made daylight manoeuvre suicidal. The situations where HVAP's penetration advantage mattered, long-range duels against heavy German armour, occurred less frequently as the war moved into its final months. Robert Earley's crew fought their last engagement on March 7, 1945, near Remagen, Germany. They encountered a Panther tank at 800 metres and destroyed it with their second HVAP round. They now carried 3, allocation having improved. The Panther's crew bailed out. No Americans died. The engagement lasted less than 2 minutes. Earley recorded his thoughts that evening in his commander's notebook, the same notebook where he had documented Captain Winter's lectures at Fort Knox. "We killed another heavy tank today," he wrote. "Used HVAP again. Still strange to have ammunition that actually works against German armour. For so long, we operated with the knowledge that Tigers and Panthers could kill us from ranges where we couldn't hurt them. That knowledge shaped everything: tactics, morale, survival instincts. Now we have rounds that change the equation. Not enough rounds. Never enough. But enough to matter. The Germans are retreating faster now. Fewer encounters. When we do engage, they seem less confident, more willing to withdraw than fight. I think they've realized that the Sherman isn't the tin can they thought it was. Or maybe they've just realized they're losing. Hard to say which matters more." The nickname, tin can, had been common among German tank crews since Normandy. The term appeared in multiple captured diaries and interrogation reports. It reflected genuine contempt for the Sherman's thin armour and perceived vulnerability. A Tiger's frontal armour was 100 millimetres thick, a Sherman's was 76 millimetres. The Tiger weighed 56 tons, the Sherman weighed 30. The comparison seemed to justify the contempt. But the contempt was based on incomplete information. German crews saw Shermans burning after being penetrated and concluded that American tanks were inferior. What they did not see was the American logistics system that replaced those burned tanks within days. What they did not account for was American industrial capacity that could produce replacement vehicles faster than Germany could destroy them. And what they certainly did not anticipate was American ordnance engineering developing ammunition that could defeat heavy armor without requiring heavy guns. The HVAP round represented a fundamentally different approach to the penetration problem. Instead of matching the enemy's armor thickness with correspondingly large guns, the approach Germany took with the 88mm and the 128mm American engineers solved the problem, with materials science and ballistics. Tungsten carbide was not a new material. It had been used in industrial applications since the 1920s. But applying it to armor penetration at scale, developing manufacturing processes that could produce tens of thousands of rounds per month, and distributing those rounds to frontline units in combat zones, that was the achievement. Not revolutionary science, but revolutionary execution. Dr. Samuel Cohen, the metallurgist who led the HVAP development project, reflected on this in a post-war interview conducted in 1948. The interview is preserved in the Smithsonian Institution's Oral History Archives. "We did not invent tungsten carbide," Cohen said. "We did not invent sub-caliber projectiles. The Germans had been using similar concepts since 1942. What we did was solve the manufacturing problem. How do you produce these rounds in sufficient quantity to matter strategically? How do you maintain quality control when you're making thousands per month? How do you distribute them to the units that need them most?" Those were engineering problems, not physics problems. And American industry was very, very good at solving engineering problems at scale. The interviewer had asked about the decision to prioritize HVAP for the 76mm gun rather than developing a larger gun for the Sherman. Cohen's response: time. We could develop and deploy new ammunition in months. Developing a new gun, testing it, redesigning the turret, modifying production lines, shipping the new tanks to Europe that would have taken years. The war would have been over. So we worked with what we had. The 76mm gun was adequate if we could improve the ammunition, and we did. The cost of that improvement was measured in tungsten. Each M93 HVAP round contained approximately 2.3 pounds of tungsten carbide. 18,000 rounds manufactured by March 1945 represented over 41,000 pounds of tungsten. That tungsten could have been used for industrial cutting tools, for armor-piercing ammunition in other calibers, for dozens of other applications. The decision to allocate scarce tungsten to 76mm HVAP production was made at the highest levels of the War Department. General Leslie McNair, commanding Army Ground Forces, personally approved the allocation in August 1944 after reviewing Aberdeen Proving Grounds test results. McNair's memo to the Ordnance Department stated, "Penetration performance against heavy German armor justifies tungsten allocation. Priority production authorized." McNair died in Normandy on July 25, 1944, killed by American bombs during Operation Cobra. He never saw the HVAP rounds his authorization made possible, but his decision to prioritize tungsten allocation for anti-armor ammunition reflected a clear understanding of the tactical problem American forces faced. German heavy armor enjoyed qualitative superiority that could not be overcome by producing more Shermans. It could only be overcome by making those Shermans more lethal. The HVAP round was part of a broader pattern in American military procurement during World War II, solving capability gaps through incremental improvements to existing systems rather than wholesale replacement. The Sherman tank itself exemplified this approach. Instead of designing an entirely new heavy tank to match the Tiger, a process that would take years, American engineers continuously improved the Sherman through better ammunition, better armor configurations, better suspensions, better fire control. The M4A3 variant, introduced in late 1944, combined the 76mm gun with horizontal volute spring suspension, giving it better mobility and a stable firing platform. The M4A3 jumbo variant added significantly thicker armor, though it retained the 75mm gun. These were not revolutionary designs. They were incremental improvements that could be implemented quickly and deployed widely. The HVAP ammunition followed the same philosophy. Not a revolutionary solution, but an effective one that could be fielded immediately. And in warfare, timing often matters more than perfection. Robert Earley survived the war. So did Corporal Voss, Corporal Holland, and Private Hayes. Private De Luca, the loader, died on April 9, 1945, killed by German artillery near the Weser River. The crew attended his funeral in New Jersey in June of 1945. Earley remembered thinking that De Luca had survived 9 months of combat, had loaded the HVAP round that killed the Tiger at Manhay, had helped keep the crew alive through dozens of engagements, only to die 3 weeks before Germany's surrender. The randomness of it seemed obscene, but war respected neither skill nor survival time. It had only mathematics and chance favoured no one. Earley returned to civilian life in September of 1945 and used his GI Bill benefits to attend engineering school at MIT. He became a metallurgical engineer, working on armour development for the Army's Ballistics Research Laboratory at Aberdeen Proving Ground, the same facility where the HVAP round had been tested. He spent 30 years developing improved armour and ammunition, retiring in 1975. In a lecture to engineering students at MIT in 1972, Earley spoke about his experience at Manhay. One of his students, David Richardson, recorded portions of the lecture. The lesson was not about tanks, Earley told his class. It was about materials. We had the same guns the Germans respected enough to avoid. We had the same armour thickness they mocked as inadequate. What changed was the projectile. Tungsten carbide travelling at 3,400 feet per second could defeat armour that steel travelling at 2,600 feet per second could not touch. That 800 feet per second difference, combined with tungsten's superior density, turned an inadequate weapon into an adequate one. Not superior, just adequate. But adequate was enough. A student had asked whether Earley thought the Sherman was a good tank. His response, "Good is the wrong question. Effective is the right question." The Sherman was effective because it existed in numbers that made German heavy armour strategically irrelevant. Yes, a Tiger could kill 5 Shermans in a duel, but we had 50 Shermans for every Tiger. And eventually, we had ammunition that let those Shermans fight back. That combination overwhelming numbers plus adequate lethality was enough to win. Earley donated his service pistol, his commander's notebook, and the spent casing from his HVAP round recovered from the battlefield at Manhay to the Patton Museum in 1989. The casing is still there, displayed alongside a cutaway M93 HVAP projectile showing the tungsten core and aluminum body. The museum placard reads, M93 HVAP T round casing, fired, the 24th of December, 1944, near Manhay, Belgium. This round penetrated the frontal armour of a German Tiger I heavy tank at approximately 500 metres, demonstrating the effectiveness of sub-caliber tungsten projectiles against heavy armour. The development and deployment of HVAP ammunition represented a significant improvement in American anti-armour capability during the final months of World War II. The placard does not mention that this was one round out of placard, 48 allocated to the entire 3rd Armoured Division in December. It does not mention that Earley carried this single round for 3 months before firing it. It does not mention the psychological burden of knowing you possess the only ammunition capable of reliably killing enemy heavy armour and having to decide when to use it. Those details are preserved in Earley's notebook, in his post-war interviews, in the memories of crews who carried HVAP rounds through the winter of 1944, knowing they might only get one shot. That mattered. Franz Kessler, the Tiger commander whose tank Earley destroyed, survived the war and returned to Germany in 1947 after spending 2 years in a POW camp in England. He worked as a mechanical engineer in Stuttgart and maintained correspondence with several American veterans, including Robert Earley. Their letters, preserved in Kessler's family archives, reveal a grudging mutual respect. In a letter dated April 1953, Kessler wrote to Earley, "I have often thought about that morning in Belgium. For 18 months I commanded Tigers and believed our frontal armour made us invulnerable to American guns. That belief died with my gunner when your round penetrated our turret. I learned later about your tungsten ammunition. In Germany, we also developed tungsten core projectiles, but production was limited and allocation chaotic. You Americans solved the logistics of deploying new technology under combat conditions better than we did. That, perhaps, is why you won. Early's response, dated May 1953. You had better tanks. No question. But we had better supply lines, better logistics, better industrial capacity, and when our engineers developed ammunition that could defeat your armor, we could produce it in quantities large enough to matter. Not large enough to give every tank unlimited rounds. I only had one that morning, but enough to change the tactical equation. War is not won by the best individual weapons. It is won by the side that can deploy adequate weapons in overwhelming numbers. The HVAP round made our tanks adequate. Our factories made them overwhelming. The correspondence between Earley and Kessler continued until Kessler's death in 1994. They never met in person. Both men said they preferred to remember each other as voices in letters rather than faces across a table. The war had made them enemies. The peace made them correspondents. Neither felt the need to make it. Friendship. The broader legacy of the HVAP round extends beyond World War II. The concept of sub-caliber tungsten penetrators became standard in anti-armor ammunition design. Modern armor-piercing, fin-stabilized, discarding sabot, APFSDS, rounds used by contemporary tanks, are direct descendants of the M93 HVAP, using depleted uranium or tungsten penetrators at velocities exceeding 1600 meters per second. The principle remains unchanged. Maximize sectional density, maximize velocity, allow the penetrator to defeat armor through kinetic energy rather than explosive force. The M93 HVAP demonstrated this principle worked at scale. Post-war ammunition development refined it. American tank doctrine also evolved based on lessons from HVAP deployment. The recognition that ammunition technology could compensate for gun size limitations influenced the decision to retain the 90mm gun on the M46, M47, and M48 tanks rather than immediately jumping to larger calibers. Better. Ammunition for existing guns provided a faster capability improvement than designing entirely new weapons systems. This approach, incremental improvement through ammunition technology, remained central to American armor development through the Cold War. The M735 APFSDS round developed in the 1970s gave the M60 tanks 105mm gun penetration, comparable to the Soviet T-62's 115mm gun. The M829 series of APFSDS rounds gave the M1 Abrams 120mm gun penetration superior to most adversary armor systems. Each generation of improved ammunition represented the same philosophy the HVAP embodied: enhance lethality through materials science and ballistics, rather than through larger guns and heavier tanks. The M93 HVAP fired in Belgium in December 1944 was the first proof that this approach could work in combat. The final irony of the Sherman versus Tiger narrative is this: the Germans were correct that their tanks were qualitatively superior. Tiger armor was thicker. Tiger guns were more powerful. In one-on-one engagements under ideal conditions, the Tiger usually won. But warfare is not conducted under ideal conditions, and strategic victory is not determined by one-on-one engagements. The Sherman succeeded not because it was better than the Tiger, but because it existed in numbers that made the Tiger's individual superiority irrelevant, and because American logistics could deliver specialized ammunition that turned qualitative disadvantage into tactical adequacy. The German crews who called Shermans tin cans were not wrong about the armor thickness. They were wrong about what mattered. Armor thickness mattered less than ammunition quality. Individual tank superiority mattered less than systemic numerical advantage. Winning duels mattered less than winning wars. And in December of 1944, when Robert Earley fired a single tungsten core round through the frontal armor of a Tiger tank at 500 meters, he demonstrated that American ordnance engineering had quietly solved the penetration problem that German armor superiority had created. Not with a bigger tank, not with a bigger gun, with a better bullet. That lesson, that materials science and industrial capacity could overcome qualitative inferiority, would shape military procurement for the next 70 years. The M93 HVAP round was not revolutionary technology. It was effective technology deployed at the right time in sufficient quantities to change tactical outcomes. Sometimes that is enough. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now and don't forget to subscribe.